We're going to go beyond the concept of a root, a square root, a cube root, fourth root of a number, and talk today about radical expressions. They're very closely tied, but there's some differences. So a radical expression looks like a root. You may even have a component that is a value that you could take the square root of, for example here, but it's also going to include some variables. In this case, we have an x squared. So when we're talking about radical expressions, we're talking about roots, whether they're square roots or cube roots, fourth roots, or whatever roots, but inside those roots are also variables of some kind. So we need to understand what it means for a root to act upon what's inside it, so that we can understand the concept of acting on a variable, something that stands in for any value. So the way we get to talk about this is by looking at the root itself. Let's look at just this straightforward one right here. Square root of x. X could be anything. X could be some number you do know, and you could take the square root of, like 25. If x is 25, this value would be 5, the square root of that 25. If x was 81, the square root of 81 is 9. So if x was 81, this value would be 9, the square root of that value. So you can understand how, even though we have a variable in the root, it's directly connected to the square roots, the cube roots, the fourth roots we've been taking. The difference being is that we're not really sure what this x value is, so we have to evaluate it based on the concept of what, in this case, a square root does to what's inside. So the concept really is that a square root, here's the definition, is the value that you would multiply by itself to get what's inside the square root sign. What this means is, if I take the square root of x and multiply it by itself, the square root of x, we're multiplying two square roots together, and therefore we're going to get the value that those square roots would give you if you multiply by themselves. This states that this value is the value you multiply by itself to get x. So when we multiply by itself, we get x. This is the concept that we have to keep in mind as we go forth with radical expressions. So, when we look up here, we're asking ourselves the question, what number do we multiply by itself to get 4x squared? What's really cool is that we can break this up into two pieces. The number piece in its own square root multiplied by the variable piece in its own square root sign. This, square root of 4, we know how to evaluate. It's just 2. This one's a straightforward one, but we can understand it conceptually and apply that concept to future square roots. What value do we multiply by itself to get x squared? What times itself is x squared? X times itself is x squared. So evaluating radical expressions involves this concept of knowing that, in this case, a square root times itself is going to give you the value inside the square root, and that we can take a square root of a product, this is 4 times x squared, and break it up into its pieces. The square root of 4 times the square root of x squared. This allows us to evaluate each of these separately. I know this one's easy. Square root of 4 is 2, and we can figure this one out, but also it's easy. The square root of x squared is x. So I like to write this just like 2x, but we have to understand where the multiplication comes from. Initially, inside the square root, we've got 4 times the x squared, but that's the same thing as the square root of 4 times the square root of x squared, and the square root of 4 is 2 times the square root of x squared, which is x, so we have 2x. Now, this is just looking at first square roots, but the concept goes into the third or the fourth roots. We just have to expand it out a little bit. For example, if we're doing a cube root of x, we're going to need to multiply it by itself 3 times in order to arrive up to that x, that's the value inside. Look at how this compares with actual values that we know. Right? If the cube root of 5 is the number you multiply by itself 3 times to get to 5, we'll have to multiply it by itself 3 times to get up to that 5. So with cube root, we need to make sure we're doing what we need to in order to multiply it by itself 3 times in order to get the value that we're going for. What this all breaks down to is that we would need to have x cubed in the cube root. Right? This is the x here times the x here times the x here, which gives us the x cubed. And this makes sense. The cube root of x cubed is x. So let's look at a few. It's pretty straightforward. What we get to do is just break it down piece by piece. So we'll go through these examples one by one. They all have different things at play, but then we'll do the breakdown afterwards. So straightforward, we've got the square root. Let's make sure we know what kind of root we're taking, of 36 times x squared. The first thing you want to do is break that product of 36 times x squared up into 2 separate square roots. This allows us to simplify a little bit and evaluate individually. Square root of 36, you can check your power chart if you don't know right off the top of your head. That's 6. And really straightforward here, the square root of x squared is just x. 6x is the square root of 36x squared. Why? Because 6x times itself, 6x, gives 6 times 6, 36, and x times x, x squared. Let's do the next one. This is a cube root. So we want to make sure that we recognize we're looking for things times themselves 3 times. You're still breaking this up into individual roots. Notice how the number is in its own root, and the variable is its own root here. We do the same thing, we just make sure those roots have 3. So we put the number in its own cube root, because we're taking the cube root of this value, and we multiply by the cube root of the variables here as well. Okay, that breakup where we separate things by multiplication, or with multiplication, still is just a single root for the number and a single root for the variable. What's the cube root of 8? Not too hard here. 2. We can just evaluate it. And cube root of y cubed, this is asking us what times itself 3 times gives us y cubed, and the answer there is just y. Y times y times y is y cubed, so the cube root of y cubed is y. Again, in other words, what we're saying here is this is the cube root of 8y cubed, because 2y times 2y times 2y. 2y times itself 3 times gives us 2, 4, 8, y squared cubed. Okay, this is just a breakdown of showing our work. Alright, this one gets a little more complicated. We've got 2 variables, x's and y's. That's okay. We'll give each of them their own square root. That's what we're dealing with. And the other thing here is that this is a 6. So we have to understand what it means to take the square root of an x that's being raised to a exponent itself. 9 x to the 6th y squared. So we've already explained really easy, straightforward how to do this one. This is going to be a 3. And this one is going to be a y. This one's going to be a little different. The question is, what times itself is x to the 6th? We have to break that down, unpack it. X to the 6th is x times x times x times x x. This is x to the 6th. So half, or a half portion of this times the other half portion is going to give us the whole product. And half portion of this is x times x times x. That's x cubed. And this other half portion is the same value, x times x times x. X cubed. So what we actually see here is that the square root of x to the 6th is going to be x cubed, because x cubed times x cubed gives us x to the 6th. X cubed times itself gives us this value, and therefore x cubed is the square root of this value. So our answer here is 3x cubed y. Alright, the next one we're looking at 4th root. Pretty straightforward. We've got the 4th root of our number, 625. Check your power chart. 4th root of 625 is 5, so that's actually just evaluated. This times 5 times 5 times 5 is 625. The other 4th root here that we're multiplying by is y to the 8th. So this one's a little trickier. What do we multiply by itself 4 times to get y to the 8th power? I'm going to break it down just like I did here with these x's. Y times y times y times y times y times y, 6, times y times y. Here's y to the 8th. We need to know how to multiply up something by itself 4 times. So since it's a 4th root, we're going to find quarter partitions, not half partitions like this one, or portions. So a quarter portion is here. Here's 1 quarter portion. Here's a 2nd quarter portion, a 3rd quarter portion, and there's the 4 quarters. We've broken up this product into 4 pieces that are the same, and each of those pieces is y squared. So y squared is going to be the 4th root of y to the 8th. Because y squared times itself 4 times gives us that y to the 8th. So the 4th root of y to the 8th is y squared. So there's a few examples in the breakdown. We'll see some little tricks and nuances that we can apply so that we get to the math easier than having to break down the concept